Today, what we are going to do is build a simple smart contract, which will help you guys to, or you guys or any users out there to deposit money like we do that in the bank. And the smart contract will work as a fixed deposit smart contract wherein, whenever you deposit money, bank will give you some amount of interest because you have locked in that amount of money for a certain period of time.
So hello and welcome everyone. Hope you are keeping well and staying safe. This is Hafsanjum and I am working as a community executive at Recro, wherein we are working towards building an exclusive community for developers to help you get connected with like-minded people, build your network and grow professionally. So those who don't know about what Recro is, it is a developer-focused platform helping developers to meet the right opportunity by connecting them with fast-growing startups such as CureFit, Udan, Swiggy, Dunzo, etc. So welcome to Recro Talks again, and today we are having a webinar on how to build your first NFT smart contract. Our guest speaker for today is Bhavya Mehta, and he's a developer freelancer by profession with Web3 companies and an explorer at heart. Currently working as a full stack lead engineer at blockchain space. He's a problem solving enthusiast, and building products is something that helps him to contribute to the developers community. And he believes that we should change the world positively and get up. And that is something that motivates him to get up from the bed every day. So thank you so much, Bhavya, for joining us. You can go ahead and say hi to the audience.
Thanks a lot, Hafsa, for a beautiful introduction. And I would like to thank Recro for giving me this opportunity to, actually speak to so many people and help share my knowledge. It has been great to have so many people here, and let's see how the session goes. Obviously, you guys know a bit about me now. But in general, I'm just a full stack engineer and have been working with Web3 companies from the past 2 years. And that's wherein my experience comes to develop or build smart contracts. And let's see, how does this go today?
Yes. Well, before we start, I would like to make some announcements. So you can post your questions in the Q&A section and I will take them up at the end of or we'll be taking it parallelly or the end of the 15 minutes of the session. And people who are joining live, I would like to announce that you can post your questions in the comment section and I would make sure to pick it up and present it to the speaker so that your questions are not left unanswered. And keep your notepad handy whenever you learn from whatever you learn from today's session. Post it on your LinkedIn, post it on your Twitter or any social account. Tag Recro, tag Bhavya, tag me, and we'll be good to go. Over to you, Bhavya. So I hope you can share the presentation now.
Perfect. So first, I'll try to quickly brief about what we are going to do in the today's session, and then we'll dive right in. So what we're going to do today is build a smart contract. There are multiple types of smart contracts out there in the world. There are NFT smart contracts. There are simple ERC20 token smart contracts. There are ERC721, which is the NFT smart contracts. There are contracts which have both, which is the NFT plus the token, which is ERC1155, like 1155, and there are other token standards. So there are a bunch of things that happen out there in the smart contract world. But today, what we are going to do is build a simple smart contract, which will help you guys to, or you guys or any users out there to deposit money like we do that in the bank. And the smart contract will work as a fixed deposit smart contract wherein, whenever you deposit money, bank will give you some amount of interest because you have locked in that amount of money for a certain period of time. I'll run you through the specifications of the smart contract when I actually start diving inside that. But that's what we are just planning to do in a gist. If you guys want to understand what are smart contracts, to just give you or help you understand in 2 lines, that is basically the API layer of a normal Web2 world. So whatever logic you would write in the backend is something that's written in the smart contract. Whatever database we use, for example, MongoDB, Firebase, or anything else, that is the blockchain. So all the data is on the blockchain. Smart contracts are the API, front end is the front end, and then there is a Web3 layer which helps connect smart contracts and the front end. Today, we are just going to explore the smart contract bit, but there are a lot of other things. There are a lot of other questions that you might have or you might want to know. So feel free to drop in those or tag me or ask me later whenever you can. And I think so we should just dive right in. So I'm going to go ahead and share my screen. Please let us know if you can. Like Hafsa, if you could let me know if my screen is visible, then that would be good.
Yes, we can see your screen.
Perfect. So this is the my compiler or the editor of choice, which is Visual Studio Code. I have set up a smart contract already using Hardhat. So if you go on to Hardhat's documentation and if you go and check how to set up a new smart contract, there's a simple command and you can run that and the whole smart contract would be set up. Going right inside the smart contract, there are two smart contracts that we have today. One is the bank.sol and ERC20 token.sol. .sol is the type of file that we are going to work on. It's called, it's like a Solidity based file. Solidity, if I have to explain or if you guys are not aware, for the people who are not aware, Solidity is a language which I would say is a combination of strong oriented programming structures or OOPS kind of language plus JavaScript. So if I mix those two, I'll get Solidity, and the syntax is very similar to JavaScript. So if you know JavaScript, I think so you should understand most of what we are going to try to do today. Now diving right in. So this is a ERC20 token smart contract. If you look over here, there is a library that I have imported, which is called OpenZeppelin. And I have imported a basic ERC20 contract from that. So OpenZeppelin is a bunch of contracts that are available, audited, and used across the world. So you can freely use them. They are, bulletproof in a way, and you don't want to write the code that is already written. So that's why we use the library OpenZeppelin to just import things that are already available. Now, why do I need a ERC20 token? So ideally, if you go and move to say Europe, if you want to go deposit something in the bank, you'll need their currency, which is euro. If you move to India, you'll need to deposit your currency, which is INR. If you go to US, you'll need USD. So similarly, because I don't have any other real currency or I don't really want to use that, like there are other tokens out there. I can use Bitcoin, I can use Ethereum, I can use Polygon, but I'm just going to deploy a token of myself, which is going to be used for testing. And this is the token that we are going to use in our bank. So this is just a new token that we are going to, deploy. Nothing to do with the session or the smart contract that we are going to develop today itself. This is just the currency that we are going to use for testing. So it's a very simple ERC20 token contract. These are generally the inputs. So the name would be the name of the contract. So it can be BTC, it can be ETH, it can be anything. So today I'm just going to name it token. The symbol will be TOK. So just the short form of token. Supply could be anything. It could be 1 million, 1 billion, 1 trillion, how much ever money you want. So basically you're able to mint money for free. So that's what we are doing today here. And then it would just, deploy the smart contract. If you look over here, this is the function we call when we deploy this. It's called mint. Mint basically means that, go and print the money and supply or send it to the person who is calling this function. So that's message.sender. So the person who deploys this contract is the person who's going to call this function, because this is inside the constructor, and he is going to call the mint function. So he gets all the money that he's planning to mint or print. So that basically means if I plan to mint 1 million tokens, I am going to get all the 1 million. So message.sender is the wallet address that calls this function or ends up calling this contract or deploying this contract. So let's go ahead and dive into the contract that we plan to develop today. So this is the bank.sol contract. Let me check this. Yeah. So again, bunch of OpenZeppelin contracts that we are using. One is for security, utils, token, and simple ones. So if you can read about these in detail, because we don't have a lot of time, I would not be able to get into each of these, but these are just helper contracts or helper functions that we can use to make sure that the contract that we are developing is also bulletproof. Going ahead, the name of my contract, I've kept it as bank because that's what we are trying to build today. This is the public token. So this is going to be the address of the token that can interact with the bank. So every bank can support different currencies or different tokens. The contract that we are going to build today will support only one token, and it could be any that you want to set, but we are going to set it to the custom token that we are going to deploy, or the test token that we are going to deploy. You can make this contract support Bitcoin. You can make this contract support Ethereum. You can make this contract support any other token out there in the market. It's just the address that you'll have to grab and supply to this contract while deploying. Now, there are a bunch of things over here, which are events. I'll talk about those later. The constructor. Constructor is generally the first function that is always called when you deploy your code or when the code runs from a file. So whenever I'm going to deploy, this is the function that's going to get called. I'm going to pass the token address that I want to support, and it is going to go and set it to this. So for now, the token address, to reiterate, is going to be the test token. Moving ahead and talking about the structure that I have created. So struct is basically a data structure, I would say, but a custom one wherein you can grab in all the other primary data structures or data types and put it into one. So fixed deposit is basically the info. So if I end up actually depositing some money into the bank, I need some kind of receipt or some kind of proof that, okay, I deposited this money. So I want to store that information in a certain way. But before that, what's the kind of fixed deposit? So if I go and open today any bank's account, like bank's application, you'll see, okay, for ICICI Bank, there are n number of fixed deposits. One is providing you 5%, one is providing you 7%, one is providing you 10%. It has different time periods. So it could say, you have to deposit for 30 days, 80 days, 365 days, or it could also ask that, okay, you are a senior citizen, or are you a male or a female? Females might get a little bit more, and things like that. So this is the info here. For our purpose, first of all, I am setting a Boolean value, which is called is active. That basically in simple terms means that is this fixed deposit active or inactive? So does the bank right now want to enroll people for fixed deposits, or bank for now is taking no money? So that is active or inactive. Interest 1 month, 3 month, 6 month, and 12 month. So what does this mean is, what's the interest that you're going to get if you deposit for 1 month? What's the interest that you're going to get if you deposit for 3 months? Similarly for 6 months and for 12 months. So 12 months is basically a year. So these are going to be the values for that. Minimum deposit. So every fixed deposit generally would have a minimum deposit. Like, how much is the minimum deposit? Can I deposit 100 rupees, 500 rupees, 10,000 rupees, or maybe 1 crore? So that's the minimum deposit value. Next is another structure that we have, or another data type that we have created, called user info. If you look over here, there are only 3 things that we are tracking. One is the amount deposited. So if I'm the user, if I'm the person who's going to go deposit, so the amount that I'm going to deposit, what's the date I deposited on? So obviously it's important, when do I deposit my money, because from then onwards, 1 month, 6 months, or 12 months is when I'm going to get the interest back. And the lock period. Lock period basically means that till, or for how much time I'm locking in those tokens or the amount that I'm depositing. So is it for, again, 1 month, 3 months, 6 months, 12 months? So these are the values that we have for now. You can obviously go ahead and support other things, or it can be a completely dynamic range wherein you can support, say, maybe 7 months or 7.5 months, or n number of things that we can do. But to keep it easy, I have kept it 1, 3, 6, and 12. Now the rewards balance. What does rewards balance mean, or why have I created that variable? So rewards balance is basically the rewards or the interest that the users are going to earn. So if I deposit, say, 1,000 rupees at an interest of 12% for a year, I should get back 120 rupees extra at the end of the year. But who pays this 120 rupees? It's ideally the bank. So the bank has to put in some money inside the smart contract or inside the bank. And that's wherein, this rewards comes in. So rewards is for making sure the bank is also putting in some money, and that money is going to be used to pay out the interest that people earn or the users earn. So these are just the variables that we have defined. Fixed deposit info that we already had, and this is a mapping. Now, what do I mean by a mapping, or what is a mapping in Solidity? First of all, if you look here, it is mapping an address to a user info. So this is the key and this is the value. So address is going to be the wallet address. If you know, or if you have heard, or if you have interacted with the blockchain space, the address basically is the unique ID that you have on the blockchain. So everything on the blockchain, like a smart contract, a user, basically has an address. So this is going to be my wallet address. You can consider this as the account number in the real world or in your current, banking world. User info is going to be the info of my account. So for my address, what is the user info? Like, what's the amount that I have deposited? When did I deposit? And for how much time do I deposit? So this is basically a key value pair of that. Now we have our first function called setup fixed deposit. If you look at the input variables, they are the same ones that we need to, set up the fixed deposit or the structure of fixed deposit needs. Two things that are important here that I've used is external and only owner. So let's first go understand what's external. So if you have understood, or if you have worked, the people out here have worked with OOPS kind of a language. There is something called public, there is something called static, something called, private. Similarly, external is a keyword in Solidity, which means that this function can only be called by the code which is external from this smart contract. So inside the smart contract, I cannot go ahead and call this function. So it's just a keyword. I can make it public. I can also make it, I cannot really make it private because I want to set it. But the difference between public and external is public, the function can also be called internally in the smart contract, but an external function can only be called outside the smart contract. The next keyword that we have here is only owner. Sorry, Hafsa, you want to say anything?
Yes, Bhavya. So I just we have a question which says, can smart contract be customized also? So around that.
So every smart contract is customized. This is also a customized smart contract. This is the code I have written. I cannot clearly understand what do you mean by customization, but all smart contracts can be customized. We are using helper smart contracts over here. So these are the helpers which are like not really customized, or you can even pick that up and customize them. But these are the helper ones. But yes, every smart contract or the smart contract that you develop is actually customized. It's just a standard that you would want to follow, but yes, you can customize.
Okay, great. Thank you.
Yeah. So coming back to only owner, this function comes from the ownable smart contract that we are using from OpenZeppelin. What does only owner mean? So this basically means that the information of the fixed deposit can be edited, can be created, and can be updated only by the bank or the person who owns the bank. So if the smart contract is deployed by, say, a particular address, that address is going to be the owner of the smart contract. And that particular owner is the only person who's allowed to change this. Again, to give you a straight parallel in our real world, in HDFC, even if you want to go ahead and earn 10% interest, you're not going to, unless HDFC decides to give you 10% interest. So HDFC is the owner. So only HDFC is allowed to change this information, or actually even go ahead and launch a fixed deposit. So I cannot go and as a user say, okay, I have 5 lakh rupees in your bank account. Now please give me a fixed deposit, which gives me 10% interest. So you cannot do that as a user. Only the bank can say, okay, you guys have this much deposit and we have started a new scheme wherein we are giving out 7% interest. Do you want to enroll? So that setup can only be done by HDFC, and that's why this function is allowed to be called only by the owner. What happens in the function itself is very straightforward. We have the variable that we have declared. We are setting the value, whether it's true or false. Obviously, whenever I'm going to create, it has to be true because that's why I'm setting it up. Interest for 1 month, 3 months, 6 months, and 12 months. And what's the minimum deposit for that fixed deposit that you are going to, create and where people can actually go and deposit. Next function comes update fixed deposit. Again, like you already created this, and then you want to update some of the information. So there are only two things that I'm allowing to update right now. I could have allowed to update everything, but one reason that I have not allowed or I have not done that way right now is to keep the whole thing simple with the limitation of time that we have. And second reason is something that it's worth thinking of. Imagine you depositing 10,000 rupees and you were told you're going to get 10% interest. 4 months later, suddenly the bank goes and updates the interest rate to 3%, and you get no information about it. Would that be okay? Would that be a good scenario? Today, the banks can do that. But because we are writing a smart contract, if you see, I have not allowed that functionality at all. Like nobody can go ahead and change the interests, right? They cannot even change the minimum deposit. So there could be an, they can change the minimum deposit to support further investors. Like for example, today they keep it to 10,000 and then in future they are okay, like we are not getting enough customers, maybe we should lower down the minimum deposit to 5,000. That is okay, but they should not be able to change how much interest people earn, because there might be people who have already deposited into the fixed deposit already. Got it? So these are the only two things that they can change. If you look at it again, simple, external, and only owner. Only owner, why? Because obviously we don't want to allow anybody to go ahead and switch on or switch off the fixed deposit. It's only the bank who should be able to do that. Next, the function that we have next is deposit rewards. Now, if you want to understand what's deposit rewards, it is very simple. If you recall or what I had mentioned about rewards, rewards are basically the tokens that are going to be used or the currency that is going to be used to give out interest to the users who have already deposited the money into the fixed deposit. So this ideally should be paid by the bank. That's why only owner. Nobody else should be paying for anybody else's interest that earns. So if I am say user A and there is another user B, B should not be paying for the interest that I earn. It should be the bank who should be paying. So that's why only owner. And this is the simple code here. Now we'll run through the code. There is a require statement here. So there is something in the Solidity world called require. It is basically a hard error. What does that mean is if the amount is zero, like does it even make sense like depositing 0 rupees inside a bank account? No, it does not make sense. So if the amount has to be greater than 0, if it is not, then just fail and don't allow this function to run. Next is rewards balance. So once the amount is correct, I have to go and update that, okay, bank has deposited 1,000 tokens, 10,000 tokens, 20,000 tokens. So I'll just update that value. I'll add the amount that has been deposited by the bank. Then I have to actually go and transfer this amount. So message.sender is going to be the bank, because only owner can call this function. Address this. So this is going to be the contract's address. Okay. And the amount. So from the bank, take the money and put it into the contract. That's what this line is going to do. And then if you see over here, there is an emit event. So why do we use events? So events are basically a way to, send out notifications or, let the world know that this is what happened on the smart contract. Not everybody are going to, go get events, but you can subscribe to them as a user. So rewards added, if you go and, look at the event that I had at the top, it basically says that, okay, rewards were added into the bank account. This basically means that, if you had already deposited money, then you are assured that, okay, the bank actually went and also put some money into the contract. So now I can get my interest, without which you won't. So that's the event. This is just a way to subscribe or, event when emitted on the blockchain, it will notify people who have subscribed to that event saying that, okay, this is something that has happened on this particular smart contract. So just kind of a notification system in simpler words. Okay, so deposit rewards. Now let's get into the actual deposit, the main function of this whole smart contract. So what do I mean by deposit is in the most simplest forms, deposit is basically going and depositing some money from your account into the bank, from your pocket into the bank. what are the two important parameters here? The amount itself, like how much do you want to deposit, and the time in months. So time in months is basically for how much time do you plan to lock this amount. Our bank contract works in a simple way wherein there is no savings account kind of functionality that we have made. In our bank account or in our bank contract, we can just go and deposit the money for a certain amount of time and you just get interest on it. So that's why you have to specify the amount of time. Let's go. Require statements, basically hard errors, or it will fail if these checks don't pass. So first of all, fixed deposit, is it active? So first of all, the fixed deposit should be active. If I wanted to go deposit into the fixed deposit, it needs to be an active one. So if it's not active, then just throw an error. Time in months. The minimum time period is 1 month because we have interest 1 month, and the maximum that we are allowing is 12 months. After which you have to go and withdraw. So that's the maximum amount of time that you're going to get. So 1 to 13. That's why these are the two checks. In solidity, if people here are not aware, or if you have a question like, can I put 1.5, or what about I can put 12.9? So decimals are not supported. So that's why it won't take up those decimals. It will, as it is, throw an error. So it's going to be a whole number. Now, again, it's a deposit function. I cannot deposit zero money. Does not make sense. So to make sure that the amount that I'm depositing is greater than zero. Now, this is very particular to my smart contract, not a real world scenario. But why do I have this? So right now, if you look at the way the smart contract is built, that every user can only have one deposit which is working or it's active. So if I already have deposited money, I cannot go and add more money without withdrawing the old one, or without the old one getting matured. Why? Because I did not want to make the smart contract complex. Can I do that in the smart contract world or in the blockchain world? For sure. I can put in 10,000 today. I can put 10,000 more tomorrow. I can put 20,000 day after, and I can keep doing that, and I can keep earning more money. But right now, our bank is going to only allow to deposit once. And if you withdraw, or if it gets matured, only after that you can go ahead and again top it up, or add more money or remove the money from it. So that's why this is the require. Like if you have already deposited, don't allow to deposit again. Now this is the logic. So the amount deposited will be amount. Block.timestamp is something that you would want to understand. Block.timestamp, like whenever you execute a transaction on the blockchain, it happens inside one particular block, or you could say at a particular time instance. That is the time instance that you are going to get here. Like what is the current time when this transaction was run? Lock period is the amount of time you are locking it for. 1 month, 3 months, 6 months, or 12 months are the options that we have. And then transfer from message.sender. So that's going to be the user, probably me, and it will get transferred to the contract. So that's basically the contract is owned by the bank. So to the bank, and then this is the amount that is going to get transferred. Token deposited is an event. It emits two things, that, okay, this is the user or the depositor who has went ahead and deposited these many tokens into the smart contract. So that's the event that you have. Next function that we have is calculate rewards. So there might be some logic that you might find a bit difficult here to understand in the first go. This code is out there on GitHub that I'm going to share the link to. It's public, so you can have a look and play around. But what does calculate rewards do? If I had to explain in a nutshell, it basically is going to calculate the amount of rewards that a person or a wallet address or a user has earned at that particular point of time. So if I deposit, say, 10,000 rupees 3 months ago, then what is the amount of interest that I've earned today? So it will just give me that number. It's basically checking, kitna mujhe interest mila. So the input is only the address because that's the only information I need. If you look over here, there are a couple of things. Public is, allow anybody to access this function. View. What does view mean? Whenever you use the keyword view, it basically means that it is not changing any information on the blockchain. It is just using the information on blockchain to calculate a particular value and return it. Or, like work on that value, but it is not changing the information. So whenever there is a function which is not changing any information of the blockchain, we declare it with the keyword view. Then returns is basically just return that value. This is the type of return. It's going to be a number. That's why you went 256. Inside the function itself, there is some logic to calculate the number of days that have passed since the deposit that has been made. Then calculate the rewards that the person earned. So, it could be lesser, more, what. So if I have to give you an example, I deposited, say, on 10th of June for 3 months. Today it's 30th July. So it's the number of months that have been passed is 1 month. It's 1 month and some more days, but the actual month that has passed is only 1 month. So how much interest should I get is the interest equivalent to 1 month. So that's all the calculation that's going to happen here. Then there are some numbers that are here. So lock period. So if it is lock period 1, basically means that is it for 1 month, is it for 3 months, 6 months, or 12 months. Multiply by the interest for 1 month, 2 month, 3 months, 6 months, or whatever, and then do some more calculation and return that value. So I'm not getting deep down inside this calculation itself because it's a bit tricky to understand if you have not written code inside Solidity already. And if you have, then I'm confident that you might have already understood this. So if you have any doubts though, in future, you can put a comment on GitHub, or you can reach out to me for sure. So, and if anybody while looking at the screen also has a doubt, please feel free to add it on the chat. So that's the function for calculate rewards. Now there are two types of withdrawals that you can do. Emergency withdrawal. Emergency withdrawal happens when there is some emergency that you happen to get into. So for example, I deposited 10,000 rupees and I thought, okay, I'm not going to need it. And suddenly, I lost my phone and I now need it because I want to buy a new phone. So this was an expense that I had not thought of, but my money was locked in inside a bank. Bank would be like, no, we are not going to give you any interest because you have locked it and we cannot give you your money back. So that's why we have an emergency withdrawal wherein you say, okay, I don't care about the interest that I am going to earn, just give me my money back. And that's the function, that's emergency withdrawal. If you look, it first basically checks that, okay, there is some amount that you have deposited, require statement. If yes, then transfer that amount to the user and just delete your information. So basically delete your fixed deposit record that, okay, you had any fixed deposit because you have already withdrawn, and then just emit the event called token withdraw. So tokens are withdrawn by this particular message, by this particular account called message sender. I hope you understood what's emergency withdrawal. Now getting into the withdraw function itself. Withdraw happens when the maturity occurs. So you deposited 10,000 rupees for a period of 3 months. So when you want to go ahead and get your money after 3 months, so you have been as a patient user who actually put in money and who should get all the rewards or all the interest that you are liable to, that's when you use the withdraw function, or you should be calling the withdraw function. So what does that do? Again, you have a require that do you actually have some amount deposited? Yes. Then go ahead and calculate the days passed. So the number of days that have passed since the deposit was made. Then check whether the days passed is greater than the lock period. So for example, why I'm calculating things in days and not in months, because we want to have the exact logic of the number of days that have passed and not just the months. Again, if you look over here, I'm just multiplying this by 30. That might not be the best way for months. There are some months which have 31 days, and there is one month which might have 28 or 29 days. But as of now, to keep it simple, I'm using 30. So for 3 months, it would be 90 days. And I have to check whether the days passed since the deposit is more than 90. So on the 91st day, I can go ahead and call the withdraw function. If it is less than that, this function will fail, saying that, okay, you cannot withdraw before maturity. Okay, then calculate the rewards that you might have accumulated. So calculate rewards is the function that we have. And if you look over here, I have declared this with public. So I can call this function inside the smart contract. I cannot call the function which I have declared with external. Okay, then make sure that rewards balance is greater than rewards. This is a very important statement, and this can fail a lot of logic if not true. So the banks have to put in some money, and that money is inside rewards balance. If they have not put in money, so you should not get rewards ideally. Like you should not be able to get any rewards because the bank has not put in money. Like you put in 10,000, you are liable to get say 1,000 rupees as interest, but there is no money that has been put into the bank that you can withdraw from. So you should ideally get 11,000, but that 1,000 should come from the bank itself, and that balance is maintained over your rewards balance. So the bank has to put in some money before you can go ahead and withdraw, or else it will not allow you to withdraw, and it will tell that not enough rewards in the contract, which basically means that the bank has not put in money for you to be able to withdraw your interest. Then calculate the total amount, which is basically the amount deposited plus the interest, which is the rewards, and then transfer that amount to the user. Reduce the rewards balance because obviously, actually, let me just put this statement here. Okay, so reduce the rewards balance and then transfer the tokens and then delete the user info because everything is done and dusted. You had a fixed deposit, you waited till maturity, you got the money that you earned, and now you have withdrawn it, and now that's why the whole transaction is complete from your end and from the bank's end, and that's why I'm going to go ahead and delete the user info. Ideally I should not be, but right now because our contract has, like, we have tried to keep it simple, we are deleting this, and after deleting you can go ahead and start another uh, deposit, or like deposit new amount again for n number of months, and then again just emit the uh, event to show to tell you or to tell the people around that okay, this user has withdrawn. So this is the smart contract. I hope you got a good brief and you understood most of it, if not all of it. uh, I'll pause like for a couple of minutes to take in any questions if you guys have across any platforms wherever you have connected from, or you could also share any more thoughts like can we do this, why have we not done that, and etc. So couple of minutes, we'll take a pause.
I think I just like have see one question which says, is this possible to record the session? Yes, we do have a live session that is already saved on a YouTube channel, so you can just go ahead and then have a look at any point that you have missed where Bhavya is explaining about the smart contracts, and also we'll have one full-fledged edited recording of this webinar that it will be out on the YouTube channel, so you could share it across with your friends or colleagues, or maybe rewatch it if you missed out on something, or watch it for more details. I'll just have a quick look on the live chat, Bhavya. I think till then we can continue over here. And if there's some question, I'll just like maybe stop you in the middle and ask.
Perfect, sounds good. So I think so that was mostly about the smart contract that I wanted to talk about. Now, after the smart contract itself, there are a couple of things which are extremely important. One is every smart contract that you develop needs to have a very robust test suite. Like you need to write n number of tests because I cannot really, test this with real currency or real money. The money might get locked. I might not get enough money back, or their kind like the withdraw function might completely fail, and all the money that I sent to the contract I cannot ever get back. There could be a number of things that can go wrong, or it can send the money to the wrong person, or deduct more money than required, and etc, etc, etc. So whenever a person develops a smart contract, because the code is immutable once it's on blockchain, you need to have a lot of testing that needs to go in. Again, to keep it easy, I have written not a lot of tests, but a few tests which can help us understand the whole flow. And that's obviously about the testing part. There is another part to the smart contract you have to go actually deploy. So as of now, let's get into the testing. So first of all, if you go, there are a bunch of libraries that I'm using. Not important to understand, but like these are the libraries that are used across the industry to test smart contracts. Solidity is just the Solidity version that that I'm using for the smart contract. Seconds in month is important for me to calculate few things below, but because a smart contract is dealing with time, wherein I want to understand what happens after 1 month, what happens after 3 months. I cannot really go in future, so I will make the code go in future and then calculate things. So that's why seconds in month. And then let's dive right in. So anybody who has written tests inside the front end, back end, they are very similar. So the framework is very similar. First, I'm going to just user describe, which is going to be the bank contract. That okay, this whole test suite is related to the bank contract. Journals are just defining that okay, these are the accounts that I'm going to use, and etc etc. So this comes right from Hardart. So Hardart uh, run engine, or the engine that we are going to run this whole thing on, will give us some accounts that we can use for testing. It will also have some money, obviously dummy money. So we are going to use that over here. These are a couple of important things that date.now. Why? Because we are setting the time to be current. It's running on an engine or a server which is locally hosted. It can take up any random time sometimes. So to avoid that, we are just setting the time right now to current time. Deploying the contracts itself. So if you remember, we had two contracts, the token contract and the bank contract. The token contract, like I told you, I'm just going to call it TOK. So this is the symbol. This is the amount that I'm going to mint. And I go ahead and just deploy this contract. After the contract got deployed, it will say, okay, the contract is deployed successfully. And similarly, the bank contract needs only one input, which is the token address. So the token address comes from this, the token that I'm going to deploy. I can put any random address here. I can put address of BTC, Ethereum, or anything. But for our testing, we are going to use the custom token that we are going to be deploying.
We just have one question, Bhavya.
Mhm.
So it's just more theoretical, nothing. I think what you're explaining right now, I guess. Will smart contracts that are backed by blockchain can empower retail banking business models?
Without a doubt, there are full-fledged banks out there. There is Aave. There is like a very new startup that's coming up. If you have read about LB Bank, so there are a
Mhm.
bunch of things that can be done. Or rather, they are a lot more powerful than the retail banks. A couple of reasons for that. I'll not dive a lot into it, but imagine I want to send money from here to USA. So if I have a bank account in HDFC and I want to send to a friend in who has an account in say New York, so Bank of New York or BNY. So if I want to do this transaction, there are a bunch of fees, a bunch of things that have to go through. The banks need a very solid infrastructure themselves. Like I cannot pick up any tier 2, tier 3 city bank. Like I cannot maybe pick up Janta Sakari Bank or some small bank and do this transaction. I need a big bank. And similarly for my friend, he also needs to have a account in the right bank, or else the transaction will become very difficult. So the infrastructure cost, the transaction cost, the time cost is a lot. Like if I do the transaction today, it might take a week, but in the blockchain space, I can do it within seconds. Like I can get his address. I have my address. Everything is out there on the internet. Like it's all digital. So within a second, like I send a file from WhatsApp to a friend in maybe America or Europe. I can do the same with money. So that's how powerful this is. That's how the retail part works. I would not say all the functionalities that a retail bank can do are as of now feasible, but yes, most of it we can. So probably the answer is yes for that.
So what will be the challenges that will come along,
So
adopting
one
a
of the
bot?
Yeah, so one of the biggest challenges that blockchain right now is facing is data. So because the amount of data that we collect, so from like if I'm putting my money into a bank, I have the whole history. When did I, start my account? What was the amount on this month, that month, and a number of things. But if you look at my contract, it's only one deposit right now. So if I delete this information, you'll not even have the information like when had you deposited the last time. There is a certain number of things maintained on the blockchain, and you can go and look out for data, but it's not very easy to fetch. So every data intensive task or every data intensive job that we have right now is going to be very difficult to implement in the blockchain. There are a bunch of things that are going around. There are sophisticated solutions which have been like people are building around to solve this data problem. But yes, we are a bit far from there right now. So one thing that I can think of which can be a bit difficult to implement right now would be insurances, because insurance needs a lot of data around when, what happened, what was the premium paid, what was the kind of car, and etc. And then if I want to satisfy that insurance claim, bunch of other things that I need to do. So insurance as a business of a bank is going to be difficult to migrate to Web3. But yes, there are companies who are trying to do that or already doing that, but not, I cannot name a company which has done it very successfully.
We have actually have an additional question to this, which says, what about the scalability and volatility of cryptocurrencies when something is backed by a blockchain, and that too, has sensitive as something like bank? Will that come as a challenge during the
So
scalability or volatility of cryptocurrencies?
scalability, no. Scalability is a completely software thing. So if the developers are out there building, it's going to be scalable, it's going to be robust, it's going to keep building. So even if the market is really down right now, I know a bunch of people who are putting their hearts out and developing a lot of things into the space. So I would not say scalability would be a problem or new things or innovation will be a problem. When it comes to the trust, when it comes to the bank operating correctly, it's going to be a challenge. It
Yes.
happens with everyone. Very recently there was a news out related to Yes Bank, or maybe a couple of years back, and the shares went down drastically. So it can happen to anyone in the real world, it can happen to anyone in the crypto world as well, that if the news that's out there is going to be bad, or people are not really trusting the system, or there are a bunch of reasons why the government is against the Web3 space, then it might cause problems. But I would not say scalability would be an issue.
Yes.
I think. So continuing, setting up the fixed deposit. So this was the function that we had. So set up fixed deposit was the function that we had, which can only be called by the bank. Okay, yeah. So both these contracts that we are deploying are going to be deployed by default by the account 0. So there are 10 accounts which the hard art run engine is going to give us. Both the, like, whenever we don't specify any account, it picks up the 0, 1 by default. So both these, if you see, I have not specified any accounts here, so they are getting deployed by 0. This function also gets called by account 0. So account 0 is the owner, because that person deployed the contracts, and that's why they can go ahead and also call the setup fixed deposit function. If you see here, these are the interest rates that I'm giving. So for 1 month, I'm going to give only 1%. For, if you go ahead and deposit for 3 months, it's going to be 6%. For 6 months, 15%, and for 12 months, 24%. So random numbers here, but to just keep the calculation easy, I've used these numbers and then actually check. So these are just some checks that I'm putting. 100 is the minimum deposit amount, so 100 rupees or 100 tokens, I could say. Now let's go ahead and deposit rewards. So deposit rewards is, again, to reiterate, done by the bank. So go ahead and deposit the rewards in and put it into the bank. As of now, I'm just deploying 1000 rupees or 1000 tokens. If you look here, this is an important step called token.approve. So whenever there are a number of cryptocurrencies out there, whenever I want a smart contract to use a particular cryptocurrency from my wallet, I have to give them permission. So if I have deposited, say, 10,000 rupees in my bank account, I have to give them permission to, use a certain amount of that. Like if you have automated bills or automated mutual fund SIPs, you give an approval for a certain amount. Bank cannot suddenly go and, instead of 10,000 rupees, pick up 20,000 rupees. You have set that limit. That is something that we are doing here, that, okay, this smart contract, so this is the smart contract address, allow this smart contract to use this much amount of money from your wallet at max. Lower is okay, higher is not okay. So you generally have to always do an approval. It's a one-time thing. For any value below this, any value above that, you'll have to do another approval, and then it will become a one-time thing for that value. So I hope you understand that. Go ahead and actually deposit the rewards. So the bank or the owner, account 0 is going to go ahead and deposit some money over here. So it's 1000 that I'm depositing, and then check the rewards balance whether it's actually 1000. Now transfer the account tokens to account 2. So if you remember, if I mint the token, the new token, the custom token, all of it is going to go to the owner. So nobody has that currency right now. It's basically RBI is printing the money, but who's the money with? With RBI itself, unless it goes out and distributes it to the other people or in the economy. Similarly, all the money was with account 0. That's why I'm going to go ahead and send some money to account number 2. So if you look here, I've started specifying account. So I'm from my account 0, who has all the money, all the tokens, I'm transferring some amount to account 2. So how much I'm transferring? 1000 rupees. Similarly, for account 3, I'm also transferring some money. That is how much? 2000. And then I'm going now for the rest of the test cases below, account 2 and account 3 are going to be the accounts or the users that are going to interact with the bank. So we have 3 accounts: account 0, account 2, account 3. Account 0 is the owner of both the contracts and it has all the money. Account 2 has 1000 rupees, if you look at over here, and account 3 has 2000 rupees. So that's what we have done till now. If you again, sorry, I did not mention, for both of these test cases, if you look, I'm using a function called token.transfer. So this transfer function I have not written anywhere. Like actually I have this transfer from, but there is like no function declaration of transfer. It comes from the ERC20 token itself. And where does ERC20 token come from? From OpenZeppelin. So this is a function provided by OpenZeppelin directly, and that's why we are using the library. Okay, going ahead. Now deposit and fixed deposit from account 2. So account 2 is going to go and deposit some money into the fixed deposit. First of all, now to do all the transaction using account 2, I'm going to connect to account 2. So like I had said, if I don't mention the account, it's account 0. But because now I want to do it from account 2, so connecting with account 2 and giving an approval to the bank contract. Okay, you are allowed to use this much money from my wallet. From the bank contract, go ahead and deposit 1000 rupees for 3 months. So if I deposit 1000 rupees for 3 months, I should ideally get at the end of 3 months 1060 at 6%, right? So that's what I'm going to get. And this is the user info. Like just check whether the amount that you deposited actually went in. Again, go ahead and deposit from account 3. If you look here, from account 3, I'm depositing 2000 rupees and I'm doing it for 6 months. For 6 months, the interest rate was 15%, I think so. Let's just check. Yeah, 15%. So for 2000 rupees at a rate of 15%, at the end of 6 months, I should get how much? Somewhere around 2000, 10, 200, 5, 300, 2300 rupees. Yeah. So that's the 300 rupees would be my interest. Cool. So let's go ahead. Now calculating rewards after 1 month. Yeah. This is only for account 1 that I'm checking. Sorry, account 2 that I'm checking. So after 1 month, because it's 6% over 3 months, 2% at the end of every month. So 2% of 1000 is 20. So I get 20 rupees at the end of first month. At the end of 2 months, I get 40 rupees. So it's after 2 months. And if you look at these 2 lines, this is just, increasing or going forward in time. So I'm saying, okay, increase time by seconds in month, or by basically by 1 month. Okay. Then after 3 months, I should have how much? 60. And the way I have written this, because you have done it for 3 months, even if you do it after 4 months, you still have 60. Like you cannot have it for more than 3 months because you had deposited for 3 months. So if you go into the bank and you deposit your money for 4 months, it's not going to pay you interest after that, because that's what you had deposited for. It will just give you the money till 4 months. So we have deposit, like we had allowed it for 3 months. So that's why 60. And even after 4 months, it's still 60 and not 80, because we have limited it to 3 months. That's the maximum time you had deposited for. Now you can do a withdraw from account 2. Okay, like I just did a directly withdraw, and the amount that I should get should be 1060 at the end of 4 months, or after any time after 3 months, because I was a patient user. I put in 1,000 rupees. I got all my interest and I got all the money back. And emergency withdraw account 3 is 2,000. So why it's 2,000? Because I did an emergency withdraw. There is no interest that the account 3 earned. And this happened because they got some urgency, or there could be some urgency that happened with account 3 and they needed the money back. Now, just to help you understand, let's do this. Oh, actually, let me do this one. So I'm writing a test case in front of you guys. So let's calculate rewards after 4 months for account 3. So all of those were for account 2, right? Let's do it for 3. So account 3 address. And after 4 months for account 3, if we check, it should be how much? Like, ideally, it should be, let me do the calculation here. So for 6 months, I get 15%, right? So for every month I get for, so let's do one thing. Actually, yeah. So after 4 months, how much I should get is 15 divided by 6, because that is for every month, and then multiplied by 4. 4 star this value. I hope you guys are understanding this. So this, and that should be the, the total interest, and then multiplied by 2,000. So let's calculate this. So it's 10. Okay. So I should ideally get 10% by the end of 4 months. Let's not increase time again, because it will become 5 months if I increase time again. So I should get 10%. 10% of 2,000 is 2,200. So let's do 200. Okay. And let's run the command. Okay, so if you go to my README file, which is also going to be on GitHub, there are also the commands that you guys can use. So this is the command we are going to use for testing. Let's do this. So if you see, everything went through, even the calculate rewards for 4 months, after 4 months for account 3. Now, if think I'm doing some fishery, or like there is some issue, let's make it as 250. And this should ideally fail, because now the calculation is wrong. Okay. So that particular test should fail and everything else should pass. So let's run it again. So it did fail. It is saying that, okay, this is a big number. Why do you see such numbers? It's just the solidity, or the blockchain way of doing it. But for now, you can ignore. But this is 200, and I'm saying it should be 250. So that's why it failed. So 200 is the right number that we have, right? So these are the tests, and that's about it for the actual testing of the contract. Also, if you see in my tests, I've written mostly the right or the happy scenarios. There's a lot of negative testing that I can do. For example, I deposit and then I try to deposit again. That should fail. I try to withdraw before the time gets done. That should fail. So a lot of checks that I have added, and you should be testing for those. I had already written tests for all those and had checked my contract, and it had worked. I have not kept those right now here, because I would have not been able to explain all of it, but that is what basically this means. Now let's go ahead and actually, look at how to deploy the contract. So environment template, these are the few things that you guys would need, and put it into a .n file. I'll not be able to show you that file, because obviously that file has my credentials, but these are the 3 things that you'll need. The testnet URL is going to be this Coven Infura.io version 3, and you go on infura.io and you'll get a key over here. You put that key over here. Etherscan API key, you get it from etherscan.io. Private key is the private key to the wallet that you're going to use. So I'm going to use MetaMask. for now. Going to the README, I have already, just a few minutes back, I had deployed the code. So I'm going to, go ahead and show you. So this is the bank contract that I had deployed. Okay. And this was done by me just a while ago before the session had started. Like we were going to have the session 2 hours ago or so. So it said create bank. And this was done by me. Uh, not going to run it again. But the command is very simple. It's there in the README file. If you go, this is the command that you'll have to use. Right now, I'm deploying it on Coven. Coven is a testnet, which is a replica of Ethereum or a Etherscan. Uh, and I'm using Coven. You can use any kind of testnet. You can use Binance testnet. You can use Polygon's testnet, which is Mumbai testnet, and you can use anything. But for now, I'm using Coven because Ethereum is widely used, and I thought that more people would be able to understand that. Going to the read contract part. So if you go here, there are a few things that I can read. So as of now, I've done nothing. I'm going to show one thing that we're going to do. So let's set up the fixed deposit. So right now there is nothing over here. Let's go and set up the fixed deposit. I have to connect to Web3. I'm going to use MetaMask. So this is the wallet of my choice. And I'm going to check whether I'm on the right account. So account one is the account that I had used. If you look over here, I have this many TOK. Why do I have these many TOK? Because I had deployed the contract and I got all the money. Nobody else has this token right now. Okay. Let me do a quick refresh to make sure I'm connected to the right wallet address. Okay. So I'm connected to the right address, right contract. I want to go ahead and set up fixed deposit. So obviously I want to set this as true. Interest for 1 month, 1. For 3 months, we had decided to be 6. I'm just putting the same values that we had in the, what do you say? The test case. And this 100, I cannot put this as 100 directly. So I have to do a thing here. Put this down. Okay. So I'll just put this as 100 with an 18 zeros, because 18 zeros are what is used in blockchain. Those who don't know, once you start understanding about the cryptocurrencies, you'll understand, like, this is just to make sure that we don't use any decimals and negative numbers in blockchain, but we need 18 zeros. So let me just count them. 100. Okay. Hopefully it's right. So I'm going to write this. So if you look here, so it says, okay, this transaction is going to go through and it won't cause a problem. Uh, I'll tell you how you can understand whether it is going to cause a problem. Say I do 24.5 decimal number. So it says an invalid amount. There's also another way. I'll maybe, like, do some other function and I'll show you. But for now, let's run this, confirm. So I actually went ahead and was able to set up this fixed deposit. Let's duplicate this site and go to the read contract. So read is the read information, write is the write information, and see whether the information got published onto the blockchain. So if you see here, I got all those values. 1, 6, 15, 24. This is what I set right now, right? And if we want to really check this, let's go ahead and, update. So what I can do update, I can just keep this as true. And let's say I want to update this to 200. So 1, 2. Okay. Sorry about having to count 18 zeros, but yeah. So again, the transaction says that it will run. So if there generally you will see an error here itself. So confirm. So view your transaction, go here and do a query again. So if you see, it became 200 over here. So this is how you can test. You can do a lot of functions from here itself. And then after this, the layer of front end comes in, wherein you can do actually go and test it from the front end or connect it to the front end, etc. But uh, etherscan.io or coven.etherscan.io provides us with this UI wherein you can call all the functions and try and test out all functions. Uh, if you guys need anything, you can obviously text me, ping me, but I have the link to these contracts inside the readme for you guys to give it a look and maybe try out functions. You'll not be able to call any functions related to the owner because I'm the owner and only I have the access right now. But if you want to try out anything, you can go ahead and deploy your version from your account and you'll become the owner and you can try things out. So if there are any changes, I'm going to just keep committing to that repo. If you find any issues, obviously reach out. And I think so that's it for the session and for everything that I wanted to talk about. I hope it was valuable and I am open to questions.
Yeah, I think we're actually done with the questions, I guess, Bhavya. And I did check, and all the questions that were asked, I brought it to you, and it was anyways insightful. And I'm glad that people actually are keen on learning such new technologies and everything. So I think we can wrap up the session. So I think, well, that brings us to the end of this wonderful session. I would like to thank each one of you for joining us. Hope you learned something from today's session. We will look forward for your post on LinkedIn and along with your key learnings. So don't forget to tag Recro, tag Bhavya, and tag me on your post. And also, Bhavya, thank you so much for joining. It was awesome having you. And thank you for taking out time and sharing such insightful information.
Without a doubt, I had a great time. Sorry if I had to rush and I could not go down deeper into everything because of the limitation of a time. Smart contracts are like today I have maybe covered just a drop from the ocean. There are a lot of things out there. There are a lot of things that you can learn from. So obviously reach out, talk to people. There are a lot of people like me out there who would be willing to help. And there's a lot of information available for free. So yeah, and Recro is doing a good job. So I hope they'll have more sessions around smart contracts.
Yeah, sure. So if anyone wants to know more deeper, dig deeper into the smart contracts and know everything, so we can get Bhavya again to just solely have a complete session or anyways mentoring us around smart contracts for who are like really interested in learning. So you can ping me about having another session around smart contracts. We'll be more than happy to get Bhavya and he'll be more than happy to explain you guys. And anyways, thank you so much for just for this wonderful session, Bhavya. So before we end the session, there's some few announcements that I want to make. So we have created a community for developers called Recro on Discord. If you're someone with if you're a developer with JavaScript experience of 2+ years, you can unleash your true potential, and you can get connected with their like-minded people, experts in the industry, and also discuss the problem and your queries over there. And we have made a LinkedIn post about the session to comment your learnings in this post. And the link of the post is also in the Instagram chat and the chat right now. So you can just go ahead and tag your learnings, tag your takeaways that we had from the session. And you can also connect Bhavya on LinkedIn. He's available on LinkedIn. He actively talks about the Web3 domain. And if you're having any questions regarding the Web3 or the blockchain or the smart contracts, feel free to just go ahead and reach out to him, connect with him, and discuss your problems and queries. He'll be more than happy to connect with you. And if you're exploring career opportunities, Recro is hiring passionate developers. And if you're someone who is looking for the change, or maybe your friends or colleagues are looking for a change, you can go ahead and check out Recro's page of recro.io/careers. So we'll be having some openings over there, and we'll make sure of placing you on the top A-grade startups of the country. And you can also follow us on social media. And important thing of this recording of the session will be on our YouTube channel. And you can go there and share this webinar with your friends and colleagues, or maybe re-look into it if you missed out on some other points. You can go ahead and subscribe to our Recro's YouTube channel, and also follow us on LinkedIn and Twitter and Instagram. And we'll have more updates on the further Recro talks that we're organizing in the coming months. And that's all for this session, guys. Thank you so much for joining us. Hope to see you in the next session. Take care. Stay safe. Thank you so much. Thank you so much, Bhavya.